Hi, this is Alexander Kolovos with Teradata Product Engineering. You are watching a Teradata TechBytes video. This is video 2 in the TechBytes series about the Teradata plugin for Dataiku. In this segment, we present the Teradata Analytic Functions Recipe of the Teradata plugin. To demonstrate the Analytic Functions recipe, we will be using the Demo Analytic Functions project that we created on this target Dataiku server. By double-clicking on the project, you see that it consists of two zones. We will be showing an instance of each one of the two major categories of functions included in the recipe. The first category is the analytics database functions. The second category are the Vantage Analytics Library series of functions, as we will be seeing in the following. Before you can use the recipe, there are a couple of requirements that must be observed. Ensure that you can go to the connection settings of the target Teradata Vantage connection that you will be using with the recipe, and specify a default database name that you will be using. If you would like to use any of the Vantage Analytics Library functions, then ensure that you also go to the custom properties of your connections and specify the special val_database connection property. This is a custom property that takes the name of a database. This is the database where the Vantage Analytics library is installed on your target Teradata Vantage server. You can acquire this piece of information from your administrator. Once you save these properties once, you do not need to repeat this process, and you can proceed with using the recipe. If a default database has not been specified in your target connection, then an error will take place when you attempt to run the recipe. Also, if you should attempt to run the recipe by specifying a val function, then you will also get an error if you have not specified a database name for the val database custom property as well. Let us begin our illustration with an instance of the analytics database functions. We go to the first zone and check the first example. So let us assume that you would like to explore a series of events that lead you to a specific result. A suitable function for this kind of analysis is the npath function that is included in the analytics database analytic functions. We assume here that we start with a bank web clicks input dataset that shows a series of clicks that occur on a website, and you would like to use the npath function to analyze these events. To simply use the recipe with this input dataset, you go under the recipe menu and click on the Teradata plugin, from where you can select the Teradata Analytic Functions recipe, and you specify the input and output of the function. Let's go back, and now inside the recipe itself, you see the interface where on top you specify the function name that you would like to use. We see here that npath is already specified here. So if we were to start from the beginning, if you click on the empty field, you can scroll down and select any of the available functions that come with the specific version of the Teradata plugin. You see that the val functions are designated with the acronym val at the end of the name. So you can either pick the function that you would like from the list, or if you already know the name of the function, which in our case is npath, you can start typing it, and you will see that the plugin will try to complete the specification of the function. So we see a couple of functions that match our typing here, and we pick npath, which is the one that we want to use. By clicking on these buttons, you can choose which functions you would like to display in the drop-down menu, so that you may or may not get to have the entire listing if you wish so. There is also a button on top that, if you click, shows you the version of the connected Teradata Vantage Analytics database. And there is also a query button that shows you the SQL query that will be submitted in the background once you have completed the fields for the specific function. So this is what we have actually done here. There is a list of required arguments, and we have provided the input that we need. And there's also a list of optional arguments as well in a separate tab. There could be some analytic functions that might require more than one inputs or outputs. To know exactly the syntax of a function, you can always follow the link on the top of the interface page, which takes you to the official Teradata documentation page for the analytic functions in Teradata Vantage. And for example, if you would like to locate the function that you would like to look for, in this case npath, you could seek for the results and look for the exact specification and syntax of npath. Back to our example now. We have all the inputs and outputs as needed, and if we should like to change those, we can go under the Input-Output tab and specify additional information as needed. And we are ready to execute that recipe with the specifications that we have. By simply clicking the Run button, the recipe executes and produces the output dataset with the results of the npath analysis. Let us go back now to the project flow and examine an instance of using the val functions in the recipe. So let us go to the second example, where we'll be illustrating usage of the decision tree functionality that is available through Teradata Vantage. We assume that we have some banking customer data in this example, and through that information with the available features, we essentially will try to predict some further information about that customer. We can start by clicking on the recipe button and invoking the Teradata plugin again, and clicking on the Teradata Analytic Functions recipe and adding the customer dataset as input to the recipe. Once we make this connection, we can go into the recipe and specify that we would like to use the decision tree val function from the list of available functions. And you see now that in our analysis, the required arguments include, first of all, the input dataset and the columns that we would like to use for the decision tree analysis. We have specified age, income, and number of children, and the response column is specified as the gender of the customer. As optional arguments, we provide the type of algorithm and pruning, and also the maximum depth and number of splits according to how we would like to run this analysis. Once we're done, the next step is to execute this recipe, and we see in the flow that the result is a decision tree model in an XML format. This format might not look that usable as we see it right here in the dataset. However, when we combine the model alongside with the original dataset, the customer analysis dataset, then we can use a couple more functions, decision tree functions, to obtain some very, very useful results. We start first with illustrating the decision tree evaluate val function, which is also available in the list of function names. And this produces the confusion matrix for this analysis. The result is a data set with a confusion matrix output. And the second function that we use by adding here another recipe that connects to the exact same input here as you see is the decision tree predict val function, which now performs the prediction on the basis of the model. Other than the required arguments of the input dataset and the decision tree model that we would like to use, we also specified in this example some optional arguments, and specifically a couple of features, input data columns, that we would also like to be included in the output dataset. So having completed the specifications, we run this recipe, and the output dataset is the CA decision tree predict, which includes all the columns that we specified, in addition to the predicted gender according to the decision tree analysis. And with this example, we conclude the illustration of the analytic functions recipe of the Teradata plugin. Thank you for watching this video, and we wish you a fine rest of your day.